Let us solve a question on utility maximization. The question is, given utility function is u is equal to xy plus 2y plus 2x. X and y are the two goods. Price of good x is $1, price of good y is $2, and income of the consumer is $18. We need to solve for the utility maximizing bundle for this consumer. Okay, so what we want to do, we want to maximize the given utility u is equal to xy plus 2y plus 2x, subject to the budget constraint, that is price of good x times units of good x plus price of good y times units of good y should be equal to the income of the consumer. Okay, so price of good x is $1, so we can write here x into 1 is x plus price of good y is 2, so in place of py we have 2y should be equal to the income of the consumer, which is $18. We want to maximize this utility function subject to this budget constraint. So we know for utility maximization, first order condition requires that the marginal rate of substitution between good x and y should be equal to the ratio of the prices, that is price of x upon price of y. MRS is, as we know, MRS is MRS is simply the marginal utility of good x upon marginal utility of good y. Okay, and marginal utility of good x is being given us by the partial derivative of utility function with respect to good x. Okay, so given this utility function, its derivative with respect to x partially is derivative of x is 1, so we are left with y, and in the next term we don't have any x, so derivative of the second term will be 0, and the derivative of last term, here we have x, its derivative is 1, so we are left with 2. Okay, similarly marginal utility of good y means the partial derivative of the given utility function with respect to good x, so partially differentiating this time with respect to y, so derivative of y in the first term is 1, so we are left with x. In the second term derivative of y is 1, so we are left with 2, and last term we don't have any y, so its derivative will be 0. Okay, so using this condition, MRS is equal to price of x upon price of y, so we have marginal utility of good x upon marginal utility of good y should be equal to the price of x upon price of good y. MUX we calculated as y plus 2, MUY is x plus 2, and it should be equal to the ratio of the prices. Price of good x is 1, price of good y is 2, so it should be equal to 1 upon 2. After that, let us solve this. So multiplying these two terms, so it becomes 2y plus 2 into 2 is 4 should be equal to x plus 2, which implies solving for let us solve for x here first. Okay, so if I transpose this here, it will become 2y plus 4 minus 2 is equal to x, which implies x is equal to 2y plus 2. Now let's plug this value of x into the budget constraint. So here we plug the value of x. So in place of x we have 2y plus 2, then we have plus 2y, it should be equal to 18. So 2y plus 2y is 4y, 4y plus 2 is equal to 18, which implies transposing this or subtracting both sides by 2, we will get 4y is equal to 16, which implies dividing both sides by 4, we will get the value of y is 4. And similarly, to find out the optimal quantity of good x, simply plug y is equal to 4 in this equation here. So we will get x is equal to 2 into 4 plus 2, that gives us the optimal units of good x is equal to 8 plus 2, which is 10. So utility maximizing bundle for this consumer is 10 comma 4. That means the consumer will consume 10 units of good x and 4 units of good y. I hope you found out this video helpful. Thank you.